Hello everybody, well done for completing the final lesson in this course, Discover the Aurora. Finally, we're just going to sum up everything we've learned in this lesson so that you're well equipped to go out and see the Aurora for yourselves. Now, this lesson was all about forecasting these great solar storm events so that humanity, society is better prepared in the future to deal with the technological implications of these extreme space weather events. We learn that forecasting and preparation are required to minimize the disruption of a great superstorm. Because if nothing else, the threat to life is pretty real. I mean, imagine if grids across the world shut down. There would be lack of heating across the board. Hospitals and hospital equipment may not work properly. The disruption of food transportation across the world because of the lack of GPS. The lack of essential communication across various different networks. Imagine nations competing for dwindling resources such as food and heat. To a certain extent, it doesn't bear thinking about. It's pretty extreme. But luckily, as a global society, we can prevent that apocalyptic scene from being painted out. It's all about getting the data and using the data. And speaking of getting the data, here is an artist's interpretation of the Parker Solar Probe doing its thing. This space probe is flying closer into the corona, the solar corona, than ever before to allow solar scientists to obtain cutting-edge data so that they can better predict the behavior of the corona, where these extreme space weather events take place, for example, solar flares and coronal mass ejections. My personal favorite, the Solar Dynamics Observatory. Most of the images and footages that you've seen of the sun throughout the duration of this course have been taken by this probe. It's been going for over a decade. It's captured some incredible scenes of the sun, planets transiting the sun, comets diving into the sun. It's absolutely amazing. It observes the sun in a variety of different wavelengths, and it has allowed solar physicists, solar scientists to obtain cutting-edge data, again, learning a huge deal about the sun. There's also NASA's Discover satellite, which monitors the speed and density of the solar wind, and it also monitors the interplanetary magnetic field located at a Lagrange point where Earth's gravity and the sun's gravity even out, so it hangs there in between the sun and Earth. It's providing us with information on solar wind coming towards us before it arrives. There's also the Solar Heliospheric Observatory, or SOHO, which studies the corona, again allowing scientists to learn more about the behavior of our star and accurately predict these space weather events. One of the most recent and cutting-edge bits of kit is the Daniel K. Inouye Solar Telescope in Hawaii. It's obtaining the highest resolution images of the visible surface of the sun so far to date. Again, allowing scientists to predict with more accuracy the behavior of these extreme space weather events. So there's a few ways in which scientists are getting this data. But using it, there also has to be procedures and changes made to grid networks across the world. The United Kingdom's grid is quite well equipped to deal with saturation from all of this solar wind, the extra saturation, the extra current coming in, generated by a geomagnetic storm wobbling around and accelerating ground-based particles. Instead of shutting everything down, in fact, the national grid would open everything out. Our grid is quite small and it's quite interconnected, and it could bear the load. Other countries, however, not so much. For example, long-distance north-south facing power lines are particularly susceptible to receiving damage, and those kind of long-distance north-south orientated power lines exist across the United States and across Australia, so they would be hit pretty hard. So that needs to change. Their grid needs updating to avoid that kind of thing. Also, building power lines on conductive ground is a good idea. At first that might seem counterintuitive. You might think, well, wouldn't it be better to build them on non-conductive ground or less electronically conductive ground? But no. If the power grid is built on less electronically conductive ground, then all of that electron flow is concentrated into the grid instead of dissipating through the ground. Building on the wrong kind of ground can magnify the damage from a great superstorm by a factor of 100, so that is incredibly important. That certainly needs updating. And really what needs to happen is the development of global procedures to ensure that resources such as food and medical care and heat are accessible despite this global disruption, particularly in developing countries. And remember, if all of that seems a little bit too apocalyptic, there would most likely be aurora visible across the entire world, so at least there's some consolation there. That takes us to the end of the Discover the Aurora course. On behalf of myself and everybody else at Keeler Observatory, thank you very, very much for signing up this course. Thank you very much for getting involved. I really do hope that you've learned a lot and you are well equipped to go out and see the aurora for yourselves. If and when you do, please do get in touch with us on social media. And if you have any images or footage of the aurora based on what you've learned here, please do share it with us as well. Thank you very, very much for getting involved, and goodbye.